This is Dr. Vineeth from SimplifiedEEEEStudies. In this session, I'm going to discuss EMF equation of alternator. So I'll be explaining the important step for deriving an EMF equation of alternator. First of all, I would like to introduce the following terms. As you can see, I have to introduce the meaning of phi. Phi is nothing but flux per pole in Weber, where P is the number of poles, Ns is nothing but synchronous speed in RPM, F is the supply frequency in Hertz, Z is the total number of conductors. Also, Z phase is nothing but number of conductors per phase connected in series. Also, T phase, that is nothing but twice the number of conductors per phase in series. So there is a relationship between the number of turns per phase and the number of conductors per phase. The number of turns per phase is nothing but the double value of number of conductor per phase. This you are supposed to note down. So these are the important terminology you are supposed to introduce first for deriving an expression for EMF induced in alternator. First of all, let us apply the Faraday's laws of electromagnetic induction. So now you can observe E average. E average is nothing but d phi by dt. We are not considering the number of turns. Right now, straight away we'll be following the equation. E is equal to n into d phi by dt. But here we are going to consider the E average, that is d phi by dt. E average is nothing but change of flux in one revolution upon the time taken for one revolution. First, you need to calculate the change of flux in one revolution. That is nothing but the number of poles into phi. Okay, where phi is the flux per pole in Weber, P is the number of poles. Now I need to calculate time taken for one revolution. That is nothing but 60 divided by ns. Now what you will do, you have to calculate the E average. How to calculate the E average? So d phi is nothing but P phi divided by 60 divided by ns. Now you are supposed to multiply with the reciprocal. That means P phi into ns by 60. So I'll be showing you the same result in the next slide. So let us move on. E average, P phi divided by 60 by ns. That is nothing but P phi ns divided by 60. I request you to call this E average equation as first equation. Next, I would like to say the total frequency of power generation is given by Pns by 120. So I'll be considering at the stator terminal, you'll be taking the power output at the stator terminal. Power will be generated at a frequency of Pns by 120. Correct? So now what you can do is, so here you look at this equation is equation for E average is P phi Ns by 120. Correct? So now separate like Pns phi by 120. Now do one thing. PNS by 120. See, PNS by 120. PNS by 120. How we can write PNS by 120? PNS by 120 is nothing but 2F. How did you get this? You already know that F is equal to PN by 120. PN by 120. So PNS by 120 can be written as 2 into F. Therefore, E average can be written as 2 phi F volts. I think it's clear to everybody. So remember that one turn is equal to 2 conductors. One turn is nothing but 2 conductors. Therefore, let me write the average value of EMF per turn is nothing but 2 into E average. Correct. 2 into 2 phi F volt. That means 4 phi F volt. Please clear the concept again. Talking about the E average as first equation. Now you are focusing on P is equal to Pn by 120. Later, see, total 120 is divided like 2 into 60, right? So here you are going to separate like 120 is nothing but 2 into 60, right? So you already know that F is equal to Pn by 120. That means Pn by 2 into 60. So Pn by 2 into 60, that what I'm going to write is 2 phi F volt, that is E average. Thereafter, what I'm going to write is one turn is nothing but 2 conductors. By the way, the total EMF E average induced is nothing but 2 into 2 phi F volt. You can ask me in case any queries. Moving further. So now, if there are T phase number of turns per phase connected in series, then the average value of EMF generated is nothing but 4F into 5 into T phase. You have to write in terms of T phase. Correct? So remember that you know one equation. So form factor is nothing but E RMS value by average value. Correct? Form factor, that is nothing but 1.11. Therefore, ERMS can be written as ERMS is nothing but 1.11 into E average. E average. E average. Therefore, 1.11 into remaining value for F5 into T phase. So ultimately, what I will get is I need to multiply 4 into 1.11. So the result is 4.44 F into 5 into T phase like volts. Moreover, this is the expression, but you have to consider two important constants like Kp and Kd. Okay. Kp is nothing but pitch factor and Kd is nothing but distribution factor. So you have to multiply these like a constant along with our EMF equation. 4.44 F5 TPH, that is the EMF equation, that should be multiplied with the Kp and Kd. So these are the Kp and Kds are concerning with the regarding the with respect to the winding of the alternator. So you have to multiply these parameters along with along with the EMF equation. All right. So ultimately, I'll be getting 4.44 F5 T phase Kp Kd. This is the ultimate EMF equation of alternator. Kindly make a note. The capital E that is expressed in terms of RMS value. So Kp and Kd. Kp is nothing but pitch factor, where Kd is known as distribution factor. So pitch factor, it is the ratio of the phasor sum of EMF induced in two sides of the coil upon arithmetic sum of EMF induced in two sides of the coil. So that is a definition. I will give the detailed explanation of pitch factor and distribution factor in the coming video. Time being, you can remember these are the constant. If Kp is equal to 1, it is full pitched, where Kp less than 1, it is short pitched coil. So even we can say like the beta can be calculated like angle beta that can be calculated by cos beta by 2. That I will discuss in the coming session. Distribution factor Kd is nothing but sine m alpha by 2 divided by m sine alpha. So where alpha is the slot angle, where m is the number of slots per pole per phase. These are the basic equation of pitch factor and distribution factor that should be considered along with the EMF equation. So ultimately, I would like to conclude. So initially, I discussed the basic terms. Later, I started with Faraday's laws of electromagnetic induction. Later, I substitute d phi is equal to phi p, dt is equal to 60 by ns. Then d phi by dt is nothing but p phi ns by 60. You know that f is equal to pn by 120. 120, I am going to divide it into 2 into 60. Therefore, pns by 60 is nothing but this 2 you are going to take into left side. That is 2f. 2f is equal to pns by 60. Okay, so now based upon that, what I'm going to do is I'll be deriving the expression for E average. Now I'll be considering one turn is nothing but two conductors. Thereafter, I'm getting the expression. I'll be converting the expression in terms of average value into RMS value, because RMS we are going to consider because we are dealing with the AC supply. Therefore, ERMS equal to 1.11 into 4F5T 5 TPH. Now, the final expression will be considered by considering pitch factor and distribution factor. I will discuss pitch factor and distribution factor in the separate video. So ultimately, you are able to get the final expression in this fashion, which I kept in a separate box. So please make use of this expression for solving the numerical example. So this is a basic design which is required for design of alternator. So we discussed the detailed derivation of EMF equation of alternator. Thank you very much for watching this video. Happy learning. Wish you all the very best for your examination.